George, congratulations on the STC, and also thank you for giving AOPA the first interview on this. So tell us, what does this all mean to you?
Well, it's a, in the immortal words of one famous politician whispering in the ear of another, it's a really BFD.
It is indeed. So, uh, so expand. Tell us what this means to the rest of us that you have this
Yeah,
STC.
you know, I I want to answer that question, but before I do, it's really important to communicate to the general aviation community uh, how very thankful we are for a lot of the support that we have gotten from the broad aviation community. A lot of that's not been visible to the pilot community, uh, but uh, one of these days, when we get a chance, we can articulate and describe a lot of that. But it's been there, and without it, we couldn't have gotten this done. Frankly, there's been a bunch of very good people in the FAA that have ultimately made this happen and made it happen right and in the right way. And I don't want to forget to make sure that people understand that. Yeah, there's been some problems, but there's been, frankly, overall a whole lot more good. It's been 12 long years, um, but this is an exciting day. I want to specifically mention that uh, the members of AOPA that have provided their dues and their other financial support and donations, that their money to AOPA has been really well spent, uh, uh, and it's some of the best dollars they've ever spent because of the support that we've had from Mark Baker and AOPA. With that, let me answer your questions.
Okay. Well, thank you very much for that, George. We appreciate it. And of course, we're all working together for the benefit of general aviation. So let's start with sort of the big picture. What does the STC mean?
Well, uh, like I say, this is a big day for the industry, uh, and it means that in a lot of our general aviation community, especially where a high fraction of the airplanes are located on the West Coast and some other sensitive locations, that relief is on the way. The cavalry, the bugle has sounded, the cavalry is coming. Uh, the regulatory hurdles every single one of them have been met and exceeded. In some cases, we've been, jumping over hurdles, over high hurdles, but we've easily cleared all those. And so it means that our industry is going to be able to go into the future and prosper and continue to provide the essential infrastructure for this country on everything from, you know, uh, angel flights for injured people to the critical training of our future airline pilots, and that's going to be able to go forward without being sidetracked by some of the environmental considerations.
So now you currently have, I guess it's on about the order of 600 STCs that allow lower compression engines to burn the G100UL. So this STC, this expands it to the higher compression engines?
So, yes, the short answer is yes, and absolutely yes. But the approved model list of engines is like 27 pages long, multiple lines on each page, and on each of those multiple lines, there's multiple makes and models. Every single spark ignition piston engine found anywhere in the FAA database is included on the approved model list. And if we forgot one of them, it was only an oversight, and we have the authority to fix that quickly.
So how much will the STC cost? Has that been established yet?
Yes, we've, you know, we try not to get the cart in front of the horse, but we've done a little bit of that, and we spent some time and some significant resources creating an online website portal, which should get opened up in the next 2, 3, 4 weeks. and it provides so people can go online and purchase the STCs. They're basically, without getting into the gory details, they're basically in the same general pricing neighborhood as what people have experienced earlier with some of the auto fuel STCs. I don't think anybody's going to have any reason to complain at all about the pricing on the STCs.
Well, that's good to hear. So, talk to me a little bit about G100UL. What exactly is it?
Well, G100UL is a trade name for G100UL high octane unleaded avgas, and it is exactly what you know what you would expect with that nomenclature. Uh, it is a complete functional drop-in replacement for 100 low lead on every airplane and aircraft in the fleet. Uh, a DC-6 that's owned by Everett's Air in Alaska that is so crucial to the infrastructure of the Native Americans in Alaska. It's on the list with its engines. Some of the most powerful, World War II era engines out there. They're included on this AML list, and all the other engines besides those.
So, can G1 can the G100UL be produced by any refinery?
So we've made this commitment. This was done with at the urging and properly so in my view of Craig Sencock and AvFuel. Craig was quick to say he didn't want to be the king of avgas, and so our arrangement is that any qualified refiner or blender of existing aviation fuels, or even if they're not, but if they're qualified to produce this, they're going to be eligible to produce it and sell it, subject to the quality assurance requirements that the FAA has approved that are part of our quality assurance manual at GAMI.
So, is it a difficult process? I mean, as we know, producing 100 low lead is a real bear for the refineries because they refine it, then they have to shut everything down and clean it, and it's a real pain. Will this just fit into the process with all of the other things coming out of the refinery?
Let me give you an example. Sitting here about 20 yards from where I'm sitting is a 10,000 gallon tank and some 2,000 gallons and 1,000 gallon tanks. And I can make a 10,000 gallon batch of this fuel on the ramp outside the door of the test cell at GAMI. I think if I can do that on this ramp, that it's not going to really be a problem for a blender or a refiner.
So, in essence, sorry, what you're just taking an unleaded gas and putting an additive in it?
No, 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 no. Uh, it takes a special combination of of traditional components in gasolines, but they have to be the right quality. You got to source them from the right places. But when you do that and you put them all together, you end up with a high octane unleaded avgas that is completely fungible in the tanks of the airplane and in the fuel tanks at the airport.
So, when you say fungible, what you're saying is that we can mix the 100 low lead and G100UL. So, I could, if I, at some place where I can't fuel up that doesn't yet have the G100UL, I can put 100 low lead into the aircraft and still not have an issue.
Yeah, I apologize for using that $100 word, fungible. It can be intermixed in any ratio and any fraction. This test cell that I'm sitting in here behind me, the FAA was here, and when we did the final detonation testing, we had what we called mongrel blends of different levels of 100 low lead and med spec G100UL, and we tested, 25, 75, 50, 50, 75, 25, and various other fractional assortments, and it all works just fine. So it makes the transition really easy because the FBO can take a tank and burn it down where there's 1,000 gallons left in a 10,000 gallon tank and dump a load of G100 avgas on top of it. And because of the wording in our specification that fortuitously we anticipated this 12 years ago, It says that that fuel in that tank, even though it's got some 100 low lead with it, remains a fuel that conforms to the G100UL specification, and therefore it is a conforming fuel. It's not hazmat.
So, talk to me a little bit about the commercialization of this. What is it going to take to get it out into the market and get it widely available?
So, this is one of those cart before the horse or chicken and egg type questions. We have been in detailed negotiations with one of the major refiners, uh, one of the largest ones, about producing this fuel. They're on board with doing this. They have provided us large volume samples 2 weeks ago today. They sent a truckload of some of their product that they arranged to take out of the heart of one of their refineries. And we've used this to make a 10,000 gallon batch of fuel on our ramp. They did this as a preliminary run, but they're very candid. They've got to get a rather large budget commitment to start changing pipes and fittings and valves and plumbing to produce this stuff. And they can't do that till the FAA had signed the STCs. Well, now we've got that done. And they're gonna be able to go to work. There are others that are now interested in doing this. We expect the phone to probably start to ring a little louder than it has in the past and more frequently.
I can imagine, particularly in California.
Yes, sir.
So, what about cost? Again, I realize until you're in full scale production and actually get it out there that costs are sort of a guesstimate, but what are we likely to see?
So, look, small volume batches cost a lot of money. And until we can get it wrapped up so that we're making millions of gallons at a time, there's going to be an incremental additional cost that's due to what I'm going to call the small volume penalty. But in volume production, when we sit there and just take a spreadsheet and look at the per gallon costs of the components that go into the fuel and figure the reasonable charges for handling and processing, in the past, when we've done that, the additional premium for this fuel has ended up somewhere between 55 and 90 cents a gallon more. Now, that was based on petroleum economics, the price of crude oil a couple of years ago when it was $50 or $60 a barrel. Some of that changes, but some of it doesn't. It's in the fixed costs. But then, the price of avgas has gone up 30 or 40% in the last 3 years, 2 years also. But it's not going to be unreasonable, and the pilots in America are not going to be paying what they're paying for avgas in Europe today.
Yeah, that's a shocker the first time you go over to Europe. I'd like to circle back around to some of the testing that you've gone through on doing this. I know that you do have one of the most sophisticated engine test cells in the business. So what kind of testing has this fuel gone through, and what has FAA done to test it?
So the engineers and managers at the Wichita Aircraft Certification Office have made the observation to us and to others in the FAA that this is the most thoroughly tested and reviewed FAA certification project in the entire history of the Wichita Aircraft Certification Office. Now, keep in mind, that's probably the single most active aircraft certification office in the country because of where it's located in Wichita. There's been at least 40 active senior FAA engineers and managers that have been actively involved in this project, and there's been at least another 50. There's really a total of around 100 altogether that at one time or another we've communicated with or have played some role or some review role. It's a really large cast of FAA personnel. I'm not sure in a short conversation how other to describe it than it's easily the most thoroughly tested, vetted, reviewed certification project that has ever come through the FAA.
Well, that should be reassuring. Let me ask you a few specific things. Materials compatibility. Now, that's always been an issue with some of the other attempts at previous blends. So, no issues with rubber fuel cells or fuel lines or anything like that?
We have not yet been able to observe anything that is frankly different than what you see with other fuel chemistries. There's a 5 or 10 year old Lycoming service bulletin that says get all those old rubber things out of your engines and aircraft compartments and put in this new high technology, Teflon type hose material. And that's been going on as a transition in our industry for 2 decades. That's good advice. But even with the traditional rubber components, we did an exhaustive 9-month accelerated material compatibility test. It was done under the direct supervision of the FAA that was here multiple times inspecting it during the interim, and there were no issues that surfaced from that.
Okay, what about altitude performance, vapor pressure, cold soak, that sort of thing?
So one of the very first tests we did was a hot day, hot fuel uh, engine operability test. We did that as back-to-back testing between 100 low lead and G100UL. There were 4 senior FAA engineers that were present here on the ramp just outside the test cell from 3 different FAA locations, Kansas City, Dallas, and Atlanta. They were all highly experienced FAA engineers. We specially custom blended multiple barrels of fuel for 100 low lead and G100 that were blended to be at the upper end of the vapor pressure range. They were something like 7.08 psi, which is just short of the upper limit. We flew. It was a September day, but it was 105 degrees outside on the ramp, for real. In spite of that, we put electric blankets on the wings and preheated the wings to even hotter temperatures. We heated the fuel to 110 degrees, put it in the hot fuel tanks, took off and flew the turbo normalized high compression 8.7 to 1 Cirrus to 26,000 feet. Shut the engine down by turning the fuel valve to off, glided down with a block airspace clearance from Fort Worth, thank them, to 14, 15, 16,000 feet. They just took the fuel valve and turned it back on. The engine promptly restarted without any issues. We did throttle slams, all that stuff. The 2 fuels were indistinguishable. If you looked at the data very, very, very closely, you would have to have said that the G100UL was very slightly less likely to create vapor lock problems than the 100 low lead was. But it's not something that you would document or put in a report.
And then the flip side, on the cold side, very cold weather?
We've done cold weather operations with snow on the ground, ice on the ground. We've not encountered anything like that. We've done laboratory cold testing with this fuel down to minus 80 and circulated it through fuel pumps and filters, and it still worked just fine.
Long-term storage, any issue with it being in the aircraft fuel tanks for months and months on end?
When we got the good folks at Embry-Riddle, and God bless Embry-Riddle for their support, specifically a shout out to them and a shout out to Cirrus for their testing, their material compatibility testing on their composite wing. But we shipped fuel to Embry-Riddle for about a year while they did an extended durability test using one of their high-time engine airplanes. And about 3.5, 4 years later, we got asked that same question. We thought, okay, well, we ought to do something. I called up Pat Anderson at Embry-Riddle, said, hey, Pat, you got any of that fuel left over? He said, let me check. He called me back, said, George, we got a barrel and a half sitting in the hangar. And I said, so it's been there from that last batch we shipped. He said, yeah, it's 3 or 4 years old. Been sitting in Daytona, Florida, for God's sakes. Ship it back to us. We want to test it. They did. We tested it. It was fine. It's much less. I mean, if you want to put something in your lawnmower and park it for 5 years, this is what you ought to put in your lawnmower and park it for 5 years. If you want to park your motorboat over the winter someplace, you want to leave fuel in the tanks, this is probably what you ought to put in them to do it.
And water, how does water in the fuel react?
Just like it does with avgas. Not well. It separates out cleanly. It's clearly visible in a hold-up ramp check for that.
Okay. So let me ask you, George. I mean, you are a small but innovative company. Uh, you're not a petroleum engineer by training. So how is it that you were able to do this and the big guys have been struggling?
That's a really good question. I've got a plaque over here on the wall that I keep in the test stand. It's a quote from. Let me read it. I'll just read it out loud. Uh, it was a famous medical meeting in 1854, and somebody challenged Louis Pasteur and said, "Well, one of his discoveries was only by chance," and his response was, "Quote: In the field of observation, chance favors only the prepared mind." Well, we've been watching the industry in 2009 for 20 years trying to find a solution to this problem. But their approach to it, frankly, was scientifically ill conceived. Their approach was we need to find a fuel that fits the existing 100 low lead Table 1 spec properties on every single line item down through the 25 line items. But it just doesn't have lead. But otherwise, it's exactly the same. Well, I thought that was, frankly, choosing words politely and carefully, ill conceived. Uh, and we looked at it and said, no, the right way to do this is to go find a fuel chemistry that works and write a specification around a fuel chemistry that works. And within 90 days, we had found a fuel chemistry that worked.
Wow.
And then started writing a specification around it. And believe it or not, we had that done by June of 2010.
So all the rest of this time has just been working through the regulators.
Yeah, and it's been, it could have gone much faster. There was a bunch of turnover in the FAA. That's kind of inevitable. There's been some parts of the FAA that were conflicted and had different views on how this should be done. Ultimately, with some good leadership, some of that came from Earl Lawrence 2 years ago, frankly, at the urging of Mark Baker to get this project moving. And then most recently, after some recent hiccups, we've got a new Air One, a lady named Larry Liu. And frankly, I've been very impressed with her. And she has stepped up and said, look, we got to quit playing around with this. We need to either do it or not do it, but we need to get it concluded. And that's been very helpful. Greatly appreciative.
Something else we probably should mention before we leave is that our engines are going to be a lot happier running on this stuff.
Oh my goodness, yes. I was just looking at some photographs last night that were taken of the inside of the combustion chamber on that engine durability run on that engine at Emery-Riddle. And I think the days of cleaning spark plugs, every 50 hours or something are going to be behind us for good. When I was a kid, a teenager, we changed the spark plugs every 10,000 miles, and in my current 6-year-old Suburban, I don't think the spark plugs have ever been changed, and it's got 80,000 miles on it.
Okay, George, I just wanted to come back again, just sort of get, we've asked this before and we sort of addressed it before, but I just want to come back around to it again, sort of timing, even just sort of a broad range as to when you think we'll really start seeing this at airports around the nation.
Well, I mean, Tim Rail, he's the president of the company, and I do the engineering work, and Tim and I deal with this problem every day, and Tim and I have shared our frustrations with this. It's going to take a while to manage the infrastructure. As you know, we had hundreds or thousands of large container ships sitting offshore at Long Beach for a year and a half, 2 years. The supply chain is still a very wounded infrastructure problem, and that's not going to make the process any easier. But I think we've got a handle on how to do this, and with the support of some of the major players in the industry that has been made manifest to us that is going to be there, I think we can start to do that. It's going to be limited to begin with, but it can be ramped up fairly rapidly. And I think by this time next year, we'll start to see this at a number of airports. and then I think it'll start to spread from there.
All right, well, George, anything else I should ask you?
I just want to emphasize again that as we go forward, all of general aviation needs to celebrate this day. And we're going to need their support as we commercialize and industrialize this and the distribution. We've had some recent very good news from one of the major flight schools on the West Coast about uptaking this for their flight school out there. I think they're probably going to be an initial rollout user of the fuel. And then I'm hoping to, as quickly as possible, provide some relief for some of these California airports and that are, being impacted by the early decisions, political decisions with respect to banning 100 low lead. So yeah, there's, it's taken a lot of effort, and there's been a lot of good effort by a lot of people. I do want to say one more time that Mark Baker has been instrumental in making sure that everybody, quit wringing their hands and started focusing on real issues.